Hey guys, this is Mainak and you're watching Civil Pro. So friends, today we'll discuss a very important topic that is column positioning. So friends, whenever a civil engineer or a structural engineer receives an architectural plan and when we have to make the structural drawing, the first thing which a structural engineer or a civil engineer needs to do is the column positioning. So there are some rules and also there are some guidelines along which we can position our columns so that when we go into our structural design we make the most possible economic design, and also we place the columns in such a way that the usability of the building is not hindered. So let's see reasons and what are the guidelines by which we can position our columns in a building. Let's get started. Columns should be located near the corners of a building. So suppose we have a building here. Now you can, all you see is the frames, which is actually the center line of the architectural plan. So now you have to place the columns. So where will you place? So let me show you. So first of all, the placing will be at the corners, which is you need to place the columns. And also suppose these are the walls or the so if there are walls, then there will be beams below the walls. So wherever the walls intersect, we can provide the columns, because ultimately the beams will also intersect. So we can provide the columns like this. So this is a start. It doesn't mean that below every intersection we should provide the column, but it are the location, these are the locations where we can provide. It is not necessary that we must provide at all intersections. Okay, coming to the second rule, we can ease into this thing. Avoid column outside your walls. So what does this mean, avoid column outside walls? So suppose we have here a plan, a single room plan. This is the door here and you have to place the columns. So if you want to place a 250 to 300 mm column and the wall thickness is 250 mm, what we can do, we can place the columns like this. That is 300 is the depth here, so it will be inside. So but if you place it at the center, it should be like this, or so this portion is going outside the wall, so it shouldn't be like this. The columns usually should stay inside the building, so we have to take that into account. Whatever the wall is, it should be flush with the wall, it shouldn't go beyond the outside of the wall. Other, if it is mentioned in architectural for architectural purposes or for design, then it's a different purpose. Generally the column is always inside the building. Next comes the orientation of a column. So orientation of a column is very, there are very many theories of the orientation of the columns, but I'll propose you a very simple thing by which you can get started. So suppose we have here a column of 250 to 350, the size is the same, and the larger size is always called the depth. So 250 to 350, this is orientation 1 and this is orientation 2. So what how can we know in which direction we need to orient the columns? So it is very important because the many things depend on this. So you need to orient the columns so that the depth of the column is contained in the major plane of bending. So what is the major plane of bending and what is the depth? We already know the depth is the the higher dimension. And why should you place it along the major plane of bending? So suppose this is a beam column plan. These are the blues are the beams and the red is the column. So this is 3.5 meter this distance and this is 10 meters. So this 10 meter, this is the major plane of bending because it has a larger distance. So this is the major plane of bending. So if we place the columns in the orientation 1, then it will be along the major plane of bending as it is done here. So every orientation here it is 1, that is along the major plane of bending. But if we provide the columns along the 2, then it will not be in the major plane of bending, it will be along the 3.5 meter distance. So by default, so if this is 3.5 meter, this will be approximately equals to like 1 point little bit more than 1.75 meters. So this will be definitely less, this distance is definitely less than this particular distance. So we need to look at the distances, or we need to look at the spans in both the planes. Whichever plane will be higher distance, that will be the major plane and will provide the orientation of the columns along the major plane of bending. And next is avoid larger center to center distances between the two columns. So suppose we have here one column and you have another column, and this is a distance. Suppose this distance is around your 15 feet. So if this distance is 15 feet, or say 16, 17, whatever the distance is, and if we provide a column in between this, suppose we at 8 feet distance we provide a column, and another distance we provide another column. So these are the two cases which we can do. So in the first case, suppose in the first case where there is no column, let's kind of increase the distance here. So let it be, the distance be around 22 feet. Okay, in the first case where there is no column, so there will be more pressure, or there will be more load on the beam. So the size of the beam will be more, or the depth of the beam will be more, and in turn the structure will be less economical. But if we place another column here, suppose at say 10 feet, then the load on the columns is reduced, and also the span of the column is reduced. So obviously there will be some cost of your footing and also the column, but ultimately the economic cost will be less for the one column and footing than giving the huge quantity of beam. Also, if you give more depth of beam, it provides an impact aesthetic, on the aesthetic view. Suppose if you have more depth, then the building will not look nice from the inside. So that's why we prefer to give columns at distances, close distances. But if you want to know what is close, you can start at 10 to 12 feet. You can provide the columns, but sometimes there is a requirement to provide no column. Suppose there is a garage, suppose there is a hall, and there is a requirement that you can't provide any column in the between. So that is a separate case. In that case, there will be false ceiling and there will be other things as well. But generally, while starting or placing columns, you will look at a distance of around 8 to 12 feet for starting, for placing the columns. Okay, and again, if you place it at a larger distance, the size of the column will be little bit more, also the beam depth will be little bit more. Okay, the next point which we can consider is we have to provide combined or strap footings for the columns along the property line. So this problem is prevalent in many parts of India. Suppose we have a another parts also. Suppose you have plot and we need to provide this along the property line, this particular column along the property line. This is the boundary line, the red, and the building is coming along the property line. So we cannot make the footing or the column beyond it. In that particular case, we have to make here strap footing like this, and we also have to provide beams, strap beams along both the direction, or else we can provide a combined footing like this and also provide the strap beam. So this is the option of making or providing columns along the property line. So now for this particular option, I want you to comment below what should be the position of the column. Will I or should I place the position of column at Q or at P? So that is P or Q. So this you have to comment below, and in the next video I will tell you if which is the correct answer, and if any one of you comments the correct answer, I will also tell that that is the right. So what, in which direction you have to think, I'll just tell you. So suppose you'll consider these two these two situations, and you will consider which one will have the minimum bending moment or balancing bending moment. And so if particular location has less bending moment or less balance bending moment, then there will be less size, it will be more economical. So this, from this angle you have to think, and you have to find out which should be the size or which should be the position of the column, whether it is P or whether it is at Q. So if you answer this, and if you also keep in mind the earlier points, earlier 5 points, so then you will get started on the column positioning and you have an idea. And after that we'll solve some practical examples in the further video to just give you more idea into the column positioning part. So that's all for today. So friends, if you found this video useful, do hit the like button. It helps to reach more people, and you can also follow me on LinkedIn. I have given the link of my profile in the description. Bye bye.